What's up everybody? Moving on to the next example. What conditions on non-zero constants a, b, c, and d ensure that the function ax plus b over cx plus d will always have a tangent with a positive slope? And the restriction on this function is that x cannot equal negative d over c, because if it does, then that denominator would be 0 and it would be undefined. Well, if we have to find conditions for the slope of the tangent to always be positive, then we know that the derivative of this function always has to be positive as well, because the derivative always gives us the slope of the tangent at any x value. So if we can find the derivative of this function here and then make it greater than 0, we could solve that inequality and see if there's any conditions on a, b, c, and d that we can get out of that. So to get the derivative of this function, we can apply the quotient rule because it's a function over another function. So to do that, we would take the derivative of that top function, which is just a, times the bottom function, which is cx plus d, minus the top function ax plus b times the derivative of that bottom function c, and then this is all over cx plus d squared, that bottom function squared. So then if we distribute that a inside the first bracket and then the c inside the second bracket and then that negative inside the second bracket as well, we would end up with a simplified numerator of AD minus BC, because this ACX and this ACX here, those will cancel out. So this is our simplified derivative, AD minus BC over CX plus D squared of this function here. So now when is this derivative going to be greater than 0? Well, if you notice, the denominator is always going to be greater than 0. Because no matter what C and D is, no matter what value we get in that bracket, whether it's positive or negative, the fact that we're squaring it, the denominator will always be positive. And the denominator can never equal 0 because we stated that restriction up here. X cannot equal negative d over c. So the denominator is always going to be positive, no matter what c and d is. However, notice in the numerator has to be positive as well. So that means that AD minus BC has to be greater than 0, because if AD minus BC is greater than 0, then a positive number divided by a positive number would give us a positive number, which would be greater than 0, which would ensure that we have a tangent that is always having a positive slope. So the final answer, the conditions on the non-zero constants, is that AD, A times D, minus BC has to be greater than 0. Or if we rearrange it, AD has to always be greater than BC. That is another final answer that we can have. So either of those work, but basically that numerator always has to be greater than 0, because if the numerator is greater than 0, then a positive number divided by a positive number, that will always happen in the denominator, is going to be a positive number. If that numerator is negative, negative divided by a positive number will be a negative number, so this condition won't hold. So in order for the derivative to be greater than 0, the numerator has to be greater than 0, or AD has to be greater than BC. So those are the conditions on the constants A, B, C, and D for this function to always have a positive slope on its tangent. Yo, what's up guys? Thanks for checking out my channel. Hopefully you got some value from the video you just watched. If you did get some value, big favor to ask you, please like this video and subscribe to the channel. Any questions, any recommendations on things you'd like to see, please leave it in the comments section. Also check out the description box below for links to material and content related to the video you just watched. Peace out.